So if you're like me, then you're a Java developer who has never really liked JavaScript. It was just that weird, quirky language that you had to use in order to get stuff done in the browser. I remember a few years ago, probably 2005, like learning about Prototype and Scriptaculous and using a little bit of that inside my web pages. And then back in 2008, 2009, when I was building the original cloudfoundry.com, we actually used Dojo as the toolkit to build the front end. And I think it was pretty much, it'd be fair to say that whenever we said the words Dojo or JavaScript, they were preceded by words that I can't actually use today. We really didn't have much fun using them. So it was sort of this Java thing, the JavaScript thing was this sort of weird language that my colleagues and myself, we never really got into. But then over the past year, I started playing around with this server-side JavaScript technology, Node.JS. And even with that, I thought server-side JavaScript was kind of a silly idea given that there's so many good choices available on the server. But strangely, over the past year, I've developed somewhat of an appreciation for the technology. It definitely has its pros. It also has quite a few cons as well. And so my goal over the course of the next hour is just to share with you my experiences, not as someone who's a Node.js expert, because I'm really just a beginner with this technology, but really as someone who's coming from the JVM world, who's really into Scala, but has also started to develop an appreciation for Node.js. So before I get into that, a little bit about me. So I actually grew up in England and then moved to the San Francisco Bay Area 23 years ago. I got my start programming in Lisp back in the late 80s. Lisp, of course, being one of those very early dynamic, functional, and object-oriented languages, which the mainstream world had features that took quite a while to become mainstream. And then eventually I ended up programming in Java, and back in 2005 I wrote the book Pojos in Action, which is all about how to build applications with Spring and Hibernate, which back then were these radically new technologies that were changing the Java world. Today we pretty much take them for granted. And then back in 2007, I started playing around with this obscure little thing called Amazon EC2. No one had really ever heard of it. Just an evangelist came and spoke at my local Java users group and blew my mind, this notion that you could rent servers by the hour and just pay back then 10 cents an hour per server. And that got me interested in cloud computing and led to my startup Cloud Foundry, which was then acquired by SpringSource shortly before SpringSource was acquired by VMware. And so today I'm sort of part of all of that. I'm a developer advocate, and I just sort of travel around, give talks on architecture, give talks on cloud computing, and so on. So here's the agenda. I'm going to spend a whole chunk of time giving an overview of Node.js. Look at the three main components of Node.js, and look at the good parts and look at the bad parts. And then I'm going to talk about what I think is a really interesting use case for Node.js, using it as a front-end server, sort of as a mediator between the browser world and between the nice enterprisey world that's written in languages that I much prefer, like Java and Scala and so on. And then I'm going to finish up by talking about promises, which is the JavaScript community's term for futures, which are a really nice concurrency abstraction for simplifying the asynchronous code that you have to write when you're programming with JavaScript and with Node. Okay, so diving in. So sort of first question is, well, what is Node? So Node is a platform. It's built on the Google Chrome V8 JavaScript engine, and its whole goal is to let you write network applications, sort of these so-called dirty apps, data-intensive real-time applications, which are really applications that don't actually do anything other than just push bytes around on the network or on the file system. And the distinguishing characteristic of it is that you write your code in this asynchronous, non-blocking style, which has the benefit of being super scalable. So Node gets a lot of buzz. No, but it turns out that the community is actually quite small when you compare it with a more mature community such as the Spring framework. So you can see that Node, the line at the bottom, is kind of growing, but it's a lot smaller than the Spring framework community. Though interestingly, the community is very, very big. You can see that like the number of downloads from the equivalent of the Maven repo is like 2 million a day. Though it's not exactly a sort of apples to apples comparison, but there's like a lot of activity within that community. So here's an example Node program that I just copied off the Node.js website. So it's a simple hello world server. So it sets up an HTTP server that responds to every request with the words hello world. So step one, you can see that it's loading the HTTP module. So we need an HTTP server. So we then go and create one. And the argument to the create server function is the request handler that gets the request and the response as arguments, and then just writes 200 and the content type and writes hello world, and we're done. And then you call .listen on that, telling it to listen on port 1337. So there's a really simple piece of code, sort of no ceremony. You just kind of edit that, create that with VI, put it in a file, and you just run it, and you have this mini app server, which, if you were to do that in Java, it would sort of take kind of a lot more code to do that. So that's just the basic hello world. So if you actually look at Node, it's really comprised, at least in my opinion, of three main parts. There's JavaScript, the language. There's the Reactor pattern. That's the asynchronous event-driven programming model that it provides. And then there's this really, really interesting module system. And there's just thousands, tens of thousands of publicly available modules. So I just kind of want to talk about each one of these components in turn, kind of looking at the good parts and looking at the bad parts. So I want to start off by talking about JavaScript. So first off, who here uses JavaScript on a regular basis? Anyone? Anyone like it? Yeah. Okay, so I apologize for anything I say that might cause offense. Okay, so JavaScript. So the first thing to note, JavaScript is a dynamic language. So dynamic in the sense that types are associated with values and not variables. And you can do things like define new program elements at runtime. So it's in the same vein as Ruby or Groovy or Lisp or so on. But where it ends up being quite different, in my opinion, is that it's weakly typed. You can do things in JavaScript that you really can't do in other languages, at least normally, like leave out arguments when you call methods, or access non-existent object properties. So it's all kind of loose. You don't get no such property exceptions thrown when you try and access a non-existent property. And you also have these weird implicit conversions that mean that 99 is actually equal to the string 99, and its notion of what's true and false in terms of a Boolean value is quite weak as well. So it's this sort of strange, weakly typed language. It's also object-oriented in an interesting way. So an object is a collection of key value pairs or properties. So we can create one here. We can access, we create an object, we assign it to Fred. We can go fred.name, which gives us back their name. We can also go fred.age, and that just comes back as undefined. Once again, that's because it's weakly typed. We can then give Fred a value that actually just adds a new property to that object. We didn't have to define it up front or anything like that. And then if we want, we can delete a property. So it's sort of very flexible, very kind of loose. JavaScript kind of sort of has the notion of classes as well. So if you look at this code, well, this is how you define a class. So you have a constructor function with a capitalized first name, and then you can go, which is kind of weird, right? And then you can define a method by going function name.prototype.method name, which is sort of kind of this really weird thing. But then it gets familiar. You can create an instance of an object by going new person, name of the constructor, function, and then passing in some arguments. And then you can invoke a method in its sort of usual kind of way. But what's really interesting about this is that the reason it looks weird is because it was trying to appear to be like Java, when in fact it actually isn't anything like Java under the covers. It's because JavaScript is not a class-based language. It actually does not have classes in the sense that Java does. You know, if you go back to the beginning of time, there's sort of two main object-oriented paradigms. You have the class-based approach, which is kind of what we know and love, but there's this alternative model, so known as the prototypal approach. So whereas in the class-based approach you have classes that define the structure and behavior of objects, in a prototypical model you don't have any distinction between classes and objects. You just have objects, and one object can inherit from another object, which is known as its prototype. So it's sort of kind of this very flat model, and the proponents of it say that it actually has some advantages. Even though, I mean, I think it's hasn't really been, even though it's a very old model, I remember reading papers about this back 20 plus years ago, it's never actually sort of caught on or been fully embraced. So in this example, we've got two objects, x and y, and x has properties a and b, and then y actually inherits from x, and it overrides the property a. So it actually inherits b from its prototype, but then defines its own value for property a. And that's actually what's happening when you define sort of these class-like things, is this, and instantiate objects with new, this is what's happening under the covers. So if you were to access it, sort of look at it kind of in the, you know, in a sort of a pure prototypal way, you know, first off, we're going to define this prototype person object. So we create an empty object and assign it to the variable person. We can then define a method called sayHello, which just prints out hello and then name. So that you can notice that name is not actually defined here. It actually has to be defined by one of the objects that inherits from this prototype. And then we can go and create some objects. So to do that, we use the object.create method. So we're not actually using new. We're sort of doing it in the more pure prototypal fashion. An object.create takes two arguments. The first is the prototype that we want this new object to inherit from, and in this case it's person. And then we can supply values for some properties. So in this case we have one object whose name is Chris and another object whose name is Sarah. And then we can go object.sayHello, and the right thing gets printed out. So it's sort of, you know, so it's actually, you know, this is more sort of, you know, the kind of the right way of using JavaScript rather than pretending that we actually have classes. And then we can, if we want, because this is a dynamic language, we can actually at runtime just override kind of give Chris its own sayHello method with totally different behavior, and that actually overrides what would otherwise be inherited from the prototype. So it's quite different from Java, despite any kind of syntactic sugar that tries to make it familiar and kind of fails badly. So JavaScript is also a functional language. So you can have function literals, you can return them from methods, and you can pass them as method arguments as well. So on this slide is an example of a make generator function that returns a function that's also a closure, by the way, that then you can call repeatedly to generate a sequence of values. So the returned closure just repeatedly applies this next function, which is passed in, and in this case just adds 1, and keeps track of the current value in a sort of local variable. So it's functional. And it also actually supports partial function application as well. So in this case, join is from a module that's really for constructing joining elements together of file to make a file system path. So you can think of it as taking a directory name and a file name and giving you the absolute path. And so it takes at least 2 arguments. But what we can do, because JavaScript supports partial function application, is partially apply it to just 1 argument. So we're just applying it, passing in x. And that gives us a new function that's called within x that we can then apply to other arguments. And that's kind of a nice trick, and you see the same kind of thing in other functional languages as well. So we can sort of just partially apply arguments and then supply the rest of them later. So okay, so it's this dynamic, object-oriented, prototypal functional language. So in a way, that's kind of nice, that if you really dig into it, JavaScript was this language that was created in a hurry, and it tried to look like Java. I mean, it's even sort of named after Java, but fails very badly in behaving like Java because it really isn't. You know, we've got sort of fake classes in there. Plus, there's some truly horrible features like there's just a global namespace. So there's no module system. And then at a lower level, there's just one confusing feature after another, like the scope of variables is confusing. If you leave out, even though it's a functional language, you still have to have a return statement. There's no implicit return value, which you just get undefined if you don't have a return statement. The way you define function literals is actually really verbose. I mean, function is a really long word. If you compare it with how you do the same thing in Scala, it's pretty messy. And there's a whole ton of confusing things about how this keyword behaves. It's actually dynamically scoped rather than lexically scoped. So if you have a method that tries to use an inner function, the value of this when the inner function is invoked is actually different than when the outer method is invoked, and it causes no source of program errors. So it's really kind of a hideous language, and it's got a few good parts, but then it's just a whole bunch of really nasty parts that, you know, you could spend a whole talk going over. So the problem we sort of have is that really, because there's, you know, JavaScript has been the only way of getting things done in the browser, because there was, for whatever reason, no sort of viable alternative really appeared, right? You know, sort of Flex came and went, Sun tried to do something and failed. Java didn't really catch on in the browser. So because of a whole bunch, not because of the merits of JavaScript, but because no one else really succeeded, we're sort of stuck with this very weird language in the browser. You know, which on the one hand, okay, well, we can just sort of deal with that. But then on the other hand, I mean, there's sort of, people have started to accept the weirdness of Java as sort of being kind of normal. So I like to think, I mean, maybe this is a little rude, but I kind of think of it as the Stockholm Syndrome, which came about when a bunch of people were held hostage in a bank in Stockholm for a number of days. And they were kind of, you know, they ended up identifying with their captors and actually defending them, and I think they ended up not wanting to be rescued. And I kind of feel that there's a large element of that going on within the JavaScript community. Apologies to anyone who is offended by that, but I think, you know, the human brain is very adaptable, very, very malleable, and as a result, you can start to take JavaScript too seriously. So, you know, so what can one do about it? Well, I think Martin Fowler, I think it was a year ago, put it really well. You know, he despairs that today in the 21st century, after all the thought and all the effort that's gone into designing computer languages, we're stuck with this JavaScript language. And so, you know, we really have to work hard to actually do some kind of damage control and just try and sort of, you know, minimize the impact. And one strategy, of course, is just to use the good parts. So, you know, Donald Crockford wrote that quite interesting book, JavaScript, The Good Parts, on defining a subset of the language that's quite good. He's also created JSLint that basically enforces a lot of those rules. So I think that's a very good strategy. Another approach is to actually use a better language that then compiles to JavaScript so that it can run in the browser. And there's quite a few of them, right? So there's TypeScript, there's Dart, there's also CoffeeScript. And you can see, you know, here's a CoffeeScript example. So it actually defines classes. There's real classes in there with real methods, and it's actually quite a lot more concise as well. And it's generally it's sort of cleaned up the spec. So there are actually other languages that compile down to JavaScript as well. So there's a few different things that we can do to make sure that we sort of limit the, we're stuck with JavaScript. So, what can we do there are a few things we can do to minimize the damage. So anyway, so that's mostly, I think that's the most negative part of my talk, is just sort of bashing the language. So I want to move on and talk about the Reactor pattern, which is the asynchronous non-blocking model that Node uses for I/O. So the Reactor pattern is actually very old. It was defined by Doug Schmidt back in 1995, back in the early days of the design pattern movement. And it's a pattern for writing scalable network servers. And the big idea here is rather than using the traditional model of having a thread per request, so like if you look at, say, Tomcat, request comes in, it gets allocated to a thread in a thread pool, which on the one hand is simple, but then there's the overhead of context switching between all of these different threads that seriously limits scalability. So instead, what the Reactor pattern is about is that you just have a single threaded event loop. So in other words, one thread that waits for an event to occur on a socket or a file descriptor, and then dispatches that event to all of the handlers that are interested in that event. So when a socket becomes ready for reading or becomes ready for writing, you will call the interested event handler, which can then process that event. This is the structure. So this is how the original pattern was defined. So there's an initiation dispatcher. So that defines an interface for registering event handlers. Each event handler is interested in one particular handle, a socket or a file descriptor. And it has a method called handleEvent that it gets called to handle the event. And then there's an event loop that just sits there waiting for events to occur on these handles. And that's handled by some the OS level select or epoll or the like. And so when an event occurs on a handle, the initiation dispatcher finds all of the interesting handlers, and then calls each one saying this event happened. So it's a pretty straightforward pattern. Has some benefits. The event handlers are sort of insulated from the lower level concerns of like listening on handles and dispatching events. It's actually quite efficient and scalable because there's no thread context switching. There's just one thread, and you don't have the overhead of switching between all these different OS threads. You don't have the memory overhead as well of the stack and so on and so forth. And then it also gives you a simplified concurrency model. It's single-threaded. So you never have the risk of multiple threads accessing the same mutable state. So there's an argument that that's quite appealing as well. Trouble is, there are some drawbacks. So number one, it's a non-preemptive model. These event handlers cannot block or can't take a long time, because that would mean that no other events can be handled. It also means that they have to work in a collaborative, cooperative fashion. One faulty event handler, then your entire server is down. And then another problem you run into is that the way that you've basically got an inverted flow of control. So if you want to perform a sequence of operations, you're sort of constantly having to go back into the Reactor, wait for the next event, then your application code gets run. And so it's actually, the code ends up being quite difficult to debug and quite difficult to understand. And I have quite a bit to say about that in a minute. So that's kind of that. So that's the foundation for the Node sort of event processing structure. And if you think about the architecture of your Node application, at the lowest level, you've got the Node event loop, basically implementing the Reactor. Above that, you have basic components like networking and file system and so on. And then above that, you have higher level components like database drivers, HTTP modules, and so on. And then above that is your application code. And at each level, except for the bottommost level, the code is listening, is basically waiting for events to occur at a lower level and getting notified. So the event loop's going to notify the socket handling code that a socket's ready for reading. That's going to notify the HTTP code that's going to start reading the header of the request. And then when it's got the header, it's going to say, call the application code saying, we've got a request. And so that's sort of, you've got multiple levels of event notification going on. And the way within Node you actually kind of process events is two different ways. So one of them is to register a callback function. So you'll just get called when an event occurs, and that's good for these one-time events. The other option is if you've got a recurring event, like, oh, there's data to be read, you can register this event listener, which will get called potentially repeatedly. So that's the model. You're just having to write a lot of callback functions and event handlers in your code. So this is, kind of, here's an example. So in Node, by convention, an asynchronous function takes a callback as the last argument. So here we're actually statting a file, find out whether it's a directory or a real file. And it takes a callback. And also by convention, that callback, the first argument to that callback is an error object. So if an error has occurred, that object that value will have a value, which is some kind of error code. And if it's undefined, then it's succeeded. And in this case, you can look, the callback looks at the stat argument to see what kind of file object. And then there's also event listeners, which, as I said, are good for these recurring events. And there's an event emitter class that you can use sort of basically as a base class, so you can use it or you can extend it. So a large number of objects that emit events use this event emitter class. It defines methods for registering event listeners. So you can just say on event name, here's my listener function. And then the code that needs to emit an event calls emit with the event name and 0 or more arguments that then get passed to the event listener. And so that's kind of it. So here's an example. So here we're reading a stream. So we're creating a, kind of like an input stream. And then I'm registering an event handler for the open event. So that just says, oh, that gets called with the file descriptor. And then I'm registering another event listener for the data event. So that will get called when there's data. So you can imagine it gets called with chunks of data. So those are the two models. And on the one hand, this looks quite simple, right? We just have event handlers. We just have callbacks and so on. The trouble is that you very quickly, in realistic applications that need to invoke lots of asynchronous services and kind of do fork and join style operations, you very quickly end up in callback hell. And it's quite messy. So here's an example. So this is sort of a little, I've just kind of simplified it somewhat. So imagine that we've got two functions, times 2, that just takes an argument, multiplies it by 2, and plus 3 that takes an argument and adds 3 to it. But to simulate an asynchronous operation, I'm actually using set timeout that only produces a value after a 500 millisecond timeout. So you could imagine, this is sort of what a database, if you try to read from a file or try to access the database, you'd get eventually your callback would get invoked. But then, okay, so then there's a scenario where we need to do plus 3 and then times 2. So we end up having to write code that looks like this. So we've got kind of callbacks within callbacks down there. So that's kind of pretty ugly. And then even worse is the scenario where we need to invoke a couple of asynchronous operations and then get the results from both of them and then call a third asynchronous operation. So sort of kind of like a fork and then a join. And you can see that, if this was, well, up here's the synchronous version, simple, right? But here's like multiple lines of code to actually do all of that, because you've got to wait. The results can come back in different order, and you have to handle that scenario. And so this is two trivial examples. You can imagine that it's more realistic code where you're calling lots of asynchronous operations. This gets pretty messy. I'm going to talk in a little bit about ways that you can simplify that. So then another big problem is, right, so we're single-threaded, and that means, well, what if we need to do a long-running computation? That's just going to block the event loop, and no other requests will get handled. So what do? So in order to handle any long-running computational blocking I/O, you actually need to do that outside of the main event loop. And there's two options. So one of them is you can use a community module that implements web worker threads. So kind of like implementing what you get in the browser, so asynchronous background threads, which I guess is okay. Or you can use the built-in module that actually forks off a child process. And that's kind of interesting because it actually provides a messaging API for the parent and child to send messages back and forth. But, and it's sort of weird in the sense that, well, this is a multi-core world, and it's kind of weird that we're sort of, having to fork off child processes because these single-threaded processes, it's kind of a real mismatch there. So I don't know how that's going to pan out over time. It's quite likely that maybe worker threads will get sort of taken out of the web browser level and become a standard part of JavaScript, but maybe not. But it's just kind of, it's sort of weird having single-threaded runtimes as standard in a multi-threaded world. All right, so that's JavaScript. We looked at that. That's the Reactor pattern. We sort of saw that on the one hand, it's quite nice, scalable, but on the other hand, we have callback hell. So I want to talk about the third part, which is really interesting, which I think is where a lot of the power comes from, namely the module system. So Node, you download it, you get a bunch of core modules for doing sort of low-level things like basic networking, TCP, UDP, HTTP, accessing the file system, timers. It's like, I did not count it, but there's probably like 20 different built-in modules. So that's pretty good. But what's really interesting is that there are thousands, well, last time I checked, there were 30,000 community modules out there for doing all kinds of things, from just basic low-level utilities to web frameworks to database drivers, messaging, you name it. There's likely to be a module for it. It's funny, one of them on there is mkdirp, and the whole purpose of that module is just to implement a function that's equivalent to make-dir-p on the command line, because the built-in one doesn't do it. So there's a very vibrant community that are just producing all of these modules. So, so what is a module? Well, basically, it's a collection of JavaScript files. It might also include some native code, because JavaScript, unlike Java, isn't a systems programming language, and so you can't really write low-level code in it. You have to resort to C, C++. Plus, there's a package file that sort of gives you metadata about the package. Installing a package is quite interesting. I kind of think like in the Maven SBT world, you have to go edit a descriptor file to say what version you have. Here you just go npm, which is the Node Package Manager, install package name. It just gets downloaded and added into your project, which is quite nice. And then once you have a module, it's easy to use. You load it using require. That gives you an object whose properties are the public exports of that module. So in this case, it's the HTTP module. And then you just call create server. And modules, I think, are very central to the whole kind of Node development system. So if you, once again, you look at the architecture of your application, at the lowest level, you've got core modules. Above that, you'd use community modules. You'd also would then write your own modules, because you want to have modularity both within your project, but also, say, across your organization as well. And then at the top, you've got your own application code. So it's sort of a very pervasive pattern. So there's a lot of modules out there, but they tend to be of variable quality. I guess that's a consequence of there just being so many. And you can very easily publish a module. So a while back, I was looking for a MySQL database driver, and I found like 10 of them, but none of them seemed to do connection pooling, or there was some other major feature written where so something that we as Java developers would take for granted as, we've had mature JDBC drivers for years. The Node community seems to be still working on it. That's partly because many of them are using MongoDB rather than just sort of boring old MySQL. So there's sort of issues. We've got lots and lots of modules, but then, the actual, there's not as many useful modules as you may think. So, so to summarize, sort of an interesting situation, right? We've got JavaScript, which is this flawed and misunderstood misunderstood language. We've got the Reactor pattern, which on the one hand is great. It gives you scalable applications, but quite a lot of the time you don't need the scalability. And it also results in callback hell. And then you also have modules, lots of modules, but not all of them are great. So in the JVM world, there's a bunch of different options out there for sort of as an alternative to this async programming model like Netty, Vertex, SpringSource just introduced a Reactor pattern, Reactor project. So sort of why care? Well, I found that, it's just easy to get stuff done, easy to write some simple network services, easy to push events from the server to the browser using Node. And that was actually really what got me interested, the ease at which you can use libraries like socket.io that I'm going to talk about in a minute to push events to the browser. So it's sort of got a role to play in modern application architecture. And I think there's sort of two reasons for that. So, number one, if you look at the structure of applications today, they've kind of evolved. Like a while back, we built these large monolithic single WAR file applications. And now they've evolved into this sort of, quote, service-oriented architecture, where there's lots of microservices that are collaborating either via REST or via RabbitMQ. So we've sort of, I hate the term SOA because it has so many hideous connotations, but really we're moving towards this microservice architecture. And then at the same time, the presentation layer of our applications has evolved as well. So whereas before we wrote these web apps that just generated HTML, and then we added some JavaScript into that HTML, and we had the model view controller pattern running inside the server with these elaborate web frameworks. Today what we have is the model view controller pattern running inside the browser, written, and we've got a whole application written there using a modern framework like Angular or Backbone or one of the others. And the role of the server has changed to serving up static content, in other words, serving up the HTML and JavaScript for the app that runs in the browser, exposing RESTful endpoints for that browser app to call, and also pushing events to the browser. And that's sort of kind of where I'm coming from. And what I see is Node actually plays a useful role as the front-end server. So it's sort of mediating between the browser world, HTML5 JavaScript app in the browser, and all of the enterprise-y services and message broker type stuff that's running on the back end. So it plays a very useful role as an API gateway, or another term for that is a front-end server. So if we look at that, one thing the front-end server needs to do is serve up static content. Turns out that's really easy to do with with Node. It's a couple of different, we could use a low-level API. So here we're creating an HTTP server that has a request handler function that's using the file system, low-level file system module to first check, it maps the URL to a file, then says, well, does the file exist? If it doesn't, replies with a 404. If it does, it writes a header with the right content type, and then it creates a read stream and then pipes that into the request. So you can see just a few lines of code. We're sort of serving up files from a tiny little HTTP server. So that's quite good. And then we can actually, even simpler than that, if we use the Express web framework, it's just a one-line configuration to say serve static content from this directory. So that's good. We can serve up static content. So the next thing to think about is, well, what about RESTful web services? Once again, that's quite straightforward. So there's actually a few different options there, but so one of them I played with is Express, and that makes it easy to do pattern matching against URLs and also destructuring to get IDs out of URLs. So here, we're implementing so we're saying for a GET request on /portfolio, grab the user ID and then go off and return their portfolio. That was, once again, that's quite straightforward. And then there's also a module called request that lets you very easily proxy requests. It's basically a higher level HTTP client library, but using that, it's quite straightforward for Node.js to act as a proxy. So a REST request comes in, you can then route it to the appropriate backend server over HTTP. And so this is actually implemented, this is a little bit of CoffeeScript. So the proxy to backend is a function that takes a URL, the base URL, and returns a request handler, a function that takes a request and response, that then proxies that request to that specified base URL. And then down at the bottom, I'm setting up various mappings. So like /restaurant gets proxied to the available restaurant URL, orders gets routed to restaurant management, and so on. Once again, pretty straightforward. And then, then there's the really interesting part of, well, how do we deliver events to the browser? Today, we want to build these real-time apps where the server's sending events to the browser and the browser's updating dynamically. And Node has some real great technologies for doing that. So here's my simple example with sort of a very state-of-the-art UI. So it's a simple counter that increments once every second. And what's interesting about this is the events are flowing from the server. And that's accomplished with this little bit of code using the socket.io event delivery module. So basically what's going on is like I'm initializing socket.io, and then when the browser connects, I'm going to show the HTML for that in a second, this sort of new connection handler just sets up uses the setInterval method to call the tick function every 1,000 milliseconds. And so what tick is doing is incrementing the counter and then emitting a tick event which gets delivered to the browser that's connecting. So quite simple, just a few lines of code there. And then here's the client-side code. So this is implemented using Knockout.js, which implements a variant of the model view controller pattern. So you can see that there's a span element with a data bind attribute that binds that span element to an attribute of the model that's defined in JavaScript. It's then connecting to socket.io, so it's connecting to the server. And then for every tick event, it's actually just updating the model, which because of the binding will then cause the span element to contain that new value. So, a real simple example, but it was just a few lines of code on the server, a few lines of code on the browser, and you've got events flowing. So I sort of have a more enterprisey version of that. So this is where the events are actually being produced by a server that publishes them to RabbitMQ, message broker, and then there's a consumer that's then subscribing to those events and then republishing them to the browser using socket.io. And that's quite straightforward as well. So here's the publisher. So it's publishing messages to AMQP. So we use the AMQP module. We connect to AMQP. We then need to make sure that the exchange that we want to publish the messages to exists. So we got to write some asynchronous code to do that. So, and when the exchange is open, we then use the setInterval to call tick, which then publishes the message via AMQP. So we're publishing the message to the TikTok exchange. It's sort of, that's the destination. And then in the client, then in the intermediary that's subscribing to the AMQP messages and then republishing them as socket.io events, sort of doing some similar things. So we're connecting to AMQP, then we're subscribing to the AMQP queue, and then for every event, every message that comes in, parsing that message and then emitting it as a tick event, which then gets picked up by the browser as before. So, there's a few details here, but you can see that it's not really, we're actually able to take these messages that are coming from our back-end systems and then deliver them very easily to the browser. And there was this kind of thing that got me interested in Node.js in the first place, kind of what started infecting my brain. Okay, so that sort of, kind of went through that kind of quickly, but that, there's the essence of building a front-end server, an API gateway using Node.js. And there's tons and tons of details that I glossed over, but it really is quite straightforward, which is really, really nice. Provided you can, deal with all the quirks of JavaScript and so on. So the final thing I wanted to talk about, which I think is a really important topic, is how to deal with callback hell. How can we write asynchronous callback style code in a way that we can understand and debug and maintain? So if you think about it, there's a couple of different scenarios. There's really, one of them is a sequential scenario where we want to do A, invoke some asynchronous operation A, and when that completes, invoke B, and then when that completes, invoke C. So that's one thing. And then there's also the fork join scenario where we want to do A and B in parallel. When they've both completed, then call C with the results. And if you write that by hand, that kind of code gets very, very messy. So there's this whole idea of concurrency abstraction, which in the JavaScript world is called a promise, and in practically every other language is called a future, which can actually help simplify the code. So the big idea here is that rather than functions taking callbacks, which that function will then ultimately invoke, instead an asynchronous function returns a promise. So a promise is an object that represents an eventual outcome, which is either a success, a value, or a failure and some kind of error code. So you can think of a promise or a future as a little box that a value will eventually appear in. So I'm the client, I call some asynchronous operation, I get back this future, and I know that at some point something will appear in that box. Java has a sort of semi-lame implementation of futures. Scala has a really great implementation. Java 8 will probably have a much better implementation. It's a very common concept. And then you use a library of functions plus with future methods to actually transform and compose promises in a really, really interesting way that actually ends up enabling you to write asynchronous code in a style that almost sort of kind of looks like you wrote it synchronously. A lot of the messy, the asynchronicity is hidden away from you. And in the JavaScript community, there's a spec that sort of defines an API, promises a/A+ spec, and then there are various implementations, one of which is when.js, which is part of Cujo.js, which is this whole kind of really, really interesting JavaScript project from SpringSource. So let's look at how you use these promises. So here's the example I used earlier, except that I've rewritten it to return a promise. So you see that there's no callback. Instead, what this code is doing, it's creating a deferred, which is JavaScript terminology for this object that represents this ongoing operation. So we call when.defer. Then we just return, that function just returns the promise of the deferred. So the deferred makes, when you make a deferred, it makes a promise as well. And then asynchronously, when there's a value to be produced that's ready, it actually calls resolve on the deferred, which arranges for that value to sort of magically appear within that promise. So, so in one sense, we haven't changed things too much. Oh dear. So, but when you look, if you look at the +3 code, that's similar, hasn't changed much. But where things have got a lot simpler is in the higher level code, where you can see that we're just doing +3, calling +3. That gives us a future, and then we're using the futures then method, which arranges to call ×2 with the value that eventually appears in that future of promise, and then gives you back a promise that contains the value that's returned by ×2. So we've sort of got rid of any of the callbacks within there, and the code's really simple. It's kind of almost synchronous in nature. And if we actually look at this example, where we're calling +3 and ×2, and then adding together the results, it's even simpler again. So we just call +3 and we call ×2. That gives us 2 of these promises, and then we use the join function. So that returns a promise that will eventually contain an array of the values from the promises that you pass in. So when joined, so that gives us an array of those 2 values, and then we call the spread method that then calls sum with the elements of that array as arguments to that function. So sum gets the 2 values and then does returns a promise that eventually has the result. So you can see that it's not quite as simple as the synchronous code, but this is before it actually took kind of the whole screen full of code to synchronize on those 2 asynchronous operations and then add the result together. So you can see how using promises really does simplify things. But then one question is, well, if you look at the raw Node APIs, they actually take callbacks, right? So how do we work with them? So one option is whenever we use a Node module API, we'd have to write code like this: create a deferred, pass in a callback that resolves or rejects the deferred, and then get the promise from that. But When has a really handy feature that lets you call a node function, and it actually supplies the callback, and you just get back a promise. So all of the boilerplate code gets hidden. We're just saying call fs_stat, file system stat with path as an argument, and nodefn.call kind of does all of this callback stuff and just gives us back a promise. So we've got this nice way of kind of integrating old style non-promise code into this nice simple promise world. And I want to finish up with a file system scanner example. So all that does is read the contents of a directory, figure out, use stat to determine which of those directory entries are files, which are directories. If they're directories, it needs to recurse, and then you kind of want to combine the results. So that's like, that's trivial to do if you're just sort of using synchronous APIs, but it's really, really messy if you don't use promises and you're using asynchronous APIs. So first thing we need to do is read the contents of the directory. So we do that with filesystem.readdir. So that's pretty simple because we're using nodefn call to do that. So that gives us a future or promise, so kind of use those 2 interchangeably, that will eventually contain an array of file names. So that's a good first step, right? Next step is, well, stat actually takes absolute path. Well, those are file names and they're relative to a particular directory. So we then have to take those directory entry names and turn them into absolute paths. Which on the one hand, it's not that big a deal, right? We can use join to do that. And it's a future containing an array, so we actually need to do some kind of map operation. And so what we're going to do is just partially apply join to the root directory, and then use when.map to map over the array that will eventually be in that promise, applying 2 absolute to each entry. So we now get back a promise containing an array of absolute paths. So, you know, this code still kind of looks sequential. We've just got all this extra kind of sort of fluff around it. So then the next step we have to do is actually invoke stat on each of those paths to determine whether it's a file or to determine whether it's a directory. So just for fun, I thought, well, let's do that in parallel. So there's actually a parallel function that will just execute a whole bunch of asynchronous stuff and give you back an array whose elements correspond to the values you get back from each of those asynchronous things. And the actual, what you have to pass to parallel is an array of functions, zero-arg functions, that it will then call. So we actually have to transform this array, this future or promise containing an array of absolute file system paths into a promise containing an array of tasks, these task functions, pass that to parallel, which is going to execute all of them, and that gives us back a promise containing an array of stat results. You know, this is the path, yes, it's the directory, no, it's a file, this is when it was created. So, you know, it's not so bad. And then the other thing we need to do is, well, if it's a directory, we need to recurse, right? So we need to actually map over the entries again. If it's a directory, we want to recurse and do everything I just described. Where if it's a file, we just want to return the name, return the path. So that will return a list of files, and so we need to balance it out by returning a singleton list there. So that gives us basically a list of files, which we then need to flatten out, or I should say a promise containing to be precise, it's a promise containing an array of files. And then we need to like flatten it, and to do that we can just use when.reduce that takes that promise containing all of the arrays and concatenates them together and gives us back another promise containing the eventual list. So we do all of that, and you can see that the code, you know, it's obviously more complicated than the synchronous code, yet at the same time, because we're using promises, we're not having to do ugly nested callbacks within callbacks. I mean, when I first wrote this, the code was just positively horrendous, and what we've got now is we're using this few weird functions like when.map, when.parallel, and when.reduce, but we've got something that's kind of looks like it's doing things sequentially, even though under the covers it's quite asynchronous. So anyway, hopefully that's given you a sense of how you can use promises to simplify your code. So, you know, that's pretty much my talk. So I sort of, you know, in summary, you know, JavaScript is one very weird, very flawed language. We have to be very careful as to how we use it, and in some cases we should really just use some language that compiles down to JavaScript like CoffeeScript. And then the asynchronous model is really interesting. On the one hand, it lets us build super scalable applications, but it adds a lot of complexity. And then this single-threaded runtime is really constraining when we actually need to do things that would otherwise block the single-threaded event loop. So there's some real challenges there. But I kind of feel that, you know, despite all of these problems, today, right now, you know, Node.js is kind of is potentially a very useful technology. You know, 2 years from now, it's quite likely that, say, in the JVM world, there will be some very robust, very easy things that are comparable to Node.js in terms of power and ease of use. I mean, you might even argue that sort of we're going to get there a lot sooner than that. But today, I think it's worth looking at Node.js and just kind of kicking the tires on it. So that's my talk. So thanks for listening. You know, you can follow me on Twitter. You can send me email. You can you'll be able to find some example code on my blog, Plain Old Objects, and you also find a copy of the slides. So thanks for listening, and I hope that you found it useful.